I have joined Discord discussions a number of times to ask flat earthers about the setting sun. And I'll show them this short video of a sunset taken from Singapore, which is almost right on the equator. And as you can clearly see from this location, the sun sets perpendicular to the horizon. And then I ask them this simple question: what path does the sun take at night to return to the east to rise again in the morning? I even try to help them out with this graphic. Of course, they've been so indoctrinated by flat earth videos, they'll tell me that it's due to perspective, and this does not answer my question. And then I'll get a perspective lesson where they tell me the sun angles down to the horizon just like a row of lights angles down to the horizon. Of course, what they ignore is that the street lights are getting closer and closer and smaller as they get farther away. And we don't see this with the sun. What we actually see is a sun that stays the same angular size and moves at 15 degrees per hour, except for some slight variations due to refraction as it nears the horizon. They will also try to convince me that the sun is different because it's at a higher altitude. Well, I've watched quite a few high-altitude jets fly overhead, and they are traveling the fastest when directly overhead, and they appear to really slow down with distance. Of course, they are also the largest when they are overhead, and they appear smaller and smaller. In fact, I've never even seen one reach the horizon because they will vanish from my sight long before that. So I did an experiment to help answer this question, and I'm going to show you how far the sun moves in 50 minutes. Now, the reason I'm using 50 minutes is because my P900 has a time-lapse setting where it takes a series of photographs for 50 minutes and puts it into a 10-second time-lapse. Now, I don't have a solar filter, but I did have two different types of welder's glass. This is 13 din, which really cuts out the glare, but it is also quite dark. So I'm using the 11 din so you can see the buildings in the background. So this will be the first time lapse. I started it when the sun was just above a building in the background, and that was about 15 minutes after sunrise. And 50 minutes represents 12.5 degrees of travel. Now, since I live about 900 miles north of the equator, you can see that the sun rises at a very steep angle compared to the horizon. And this is the second time lapse. Now, of course, the sun is going to continue on that same path at 12.5 degrees every 50 minutes. Of course, I also know that the sun was on this same path before sunrise, so of course that path was below the horizon. And here's a single video looking to the west of a sunset. Now, the condo that I live in is about 13.4 degrees north of the equator, which means that the angle of the setting sun to zenith is also at about 13.4 degrees. Now, this is a graphic showing the path of the sun that I see on the equinox when the sun is rising to the east and setting in the west. And this represents the sun 1 and 2 hours after sunrise and 1 and 2 hours before sunset. Now, I think it's pretty obvious that this observed sun path does not work on a flat Earth. The North Pole is 6,218 miles in this direction, so I mean the sun would literally have to go down, take a hard right turn, go around the North Pole, again take another hard turn to rise in the east in the morning. That makes absolutely no sense at all. Now, what does make logical sense is the sun continuing on the same path after sunset. So the path of the sun at night is just the opposite of the path that we see during the day. In fact, my 6-year-old step-grandson was able to figure this out when I asked him one day, where does the sun go at night? He only thought about it for a few seconds and he pointed to the floor. Well, I've also been asked by flat earthers, well, do you have X-ray vision? No, this is just using common sense. The path of the sun is not going to change just because it's at sunset or sunrise. It would be similar to watching a high-altitude jet on a straight path go behind a cloud. You don't need X-ray vision to understand where that jet would reappear again. Now anybody can do this from their location. This is from my hometown in Seattle. This is the Space Needle right here, and these are the Olympic Mountains to the west. Now, since Seattle is quite a bit farther north of the equator than Bangkok or Singapore, the angle of the setting sun to the horizon is not nearly as steep. But again, all we need to do is continue this line and we can clearly see that the sun continues on the same path below the horizon. And if we know where the sun is 1 hour before sunset, we can make a very accurate estimation of where that sun is 1 hour after sunset. And again, using the equinox as an example, this is the path of the sun that I see during the day in Seattle. So again, the path of that sun at night is the opposite of the path that I see during the day because that sun is not going to change direction at the horizon. Now the next question is, do these observations work on a globe? So let's start with Singapore. So again, here's the observed path of the sun from Singapore on the equinox, and this would be at noon when the sun is overhead. And this is what it looks like on the globe, and of course you can see that I rotated the globe 90 degrees so that Singapore is on the top with the noon sun overhead. Now, of course, on the globe, it is actually Earth rotation that makes it appear that the sun is moving. So this would be at about 3 p.m. And this would be at sunset when Singapore is on the terminator line. So the next question is, does this work on a globe for Bangkok and Seattle? So I've changed my graphic a little bit. This is still going to be the equinox sun. And here we have the path of the sun in direct alignment with the equator. So on the equinox, the angle of the sun from zenith is about 13.4 degrees from my condominium and about 76.6 degrees from the horizon. This is my approximate location north of Singapore on a globe. This line would be zenith from my location with the noon sun to the south of me. And we can see that this is a match to the path of the sun that I actually see. This is the observed path of the sun that I saw in Seattle. 47.6 degrees is the path of that sun from zenith, and 42.4 degrees is the path of that sun from the horizon. Now each of these latitude lines here equals 10 degrees, so this would be the approximate location of Seattle on the globe in relationship to Bangkok and Singapore, and this would be zenith. Now, like everywhere else in the Northern Hemisphere, the observed setting sun angles down to the north. And again, this observation matches the globe model. Let's add one more observation, though. This is from Ningaloo Reef in Western Australia. And do you notice something? Well, if you've ever been to the Southern Hemisphere, you quickly see that the setting sun angles down to the south. Now this is what that sun path looks like on the equinox, and again from the noon sun that path angles down to the south. And I spent over a year in Australia. I have seen this with my own eyes. Now Ningaloo Reef is at about 23 degrees south. This would be its approximate location in relationship to Singapore, and again here is zenith from that location. And again, the sun path angles down to the south, not to the north. And surprise, surprise, this also works on a globe. Well, it is pretty self-evident that these observations of a setting sun from 4 different locations around the world cannot be explained by a flat Earth. The sun does not just go farther away due to perspective. What it does is what we see on the right. It continues on the same path below the horizon at night as it returns to the east to rise again in the morning, because we live on a globe.